Hi everyone, welcome to Dento'ZEN. We are going to continue with the topic of properties of dental materials. Last class we discussed that these can be physical properties and mechanical properties, and they are based on certain laws like that of thermodynamics, optics and mechanics. Now, another thing that we can discuss is based on the flow characteristics of the materials, and we study them under a branch which is known as rheology. So, under this, we have two important terms which are known as creep and flow. Now, creep and flow can come as a short note for your exam. So, let's start this topic. Before starting, quickly subscribe to Dento'ZEN, tap on the like button, and hit the bell icon so that you remain notified about new videos. Last lecture we discussed that all matter is made up of atoms. These atoms are arranged to form crystalline materials or non-crystalline materials. Now these materials which are used inside the mouth, the dental materials inside the mouth, do you think they are always under stable conditions? No. Why? Because the temperature inside the mouth may be changing based on the type of food we consume. Moreover, there may be constant forces which may be acting upon these materials inside the mouth. So, with that comes the two important terms that you need to first know before understanding creep and flow. So, the first term is stress. Now, what is stress? Whenever these forces are acting upon the material will develop certain resistance to that force. So that resistance which is developed inside the material is called stress, and this will be equivalent to the external force which is acting upon it. So we can say basically the stress is the force which is acting upon the material per unit area of the material. Now, what do you think when these forces are acting upon the material, these materials will remain the same or will change? What happens when you are stressed? Do you feel the same or you feel certain changes are happening? Yes, so certain changes happen in the material because of these constant forces. There will be distortion of the material. So, that change that happens is given the term strain. So, what is strain? Strain is basically the change in the dimension of the material per unit its original dimension. So, the two important terms are stress. Stress is the force acting upon the material per unit area, and strain is the distortion that happens in the material due to this stress, and that will be measured as change in its dimension per unit its original dimension. Now, let's understand what is creep and flow. So, let's imagine we have some metal in the mouth, metal being used as restoration. So this metal material which is placed in the mouth may be present at a constant temperature which is near to its melting point. So when a metal is held at the temperature which is near its melting point in the mouth, and also certain kind of constant forces acting upon it, that is constant stress is there, it is subjected to constant applied stress, what will happen? There will be strain, that is distortion. So these two things will result into a strain which will increase over time. So that is how creep happens, that the strain that is happening is basically called creep. So two important things that you have to remember is that when a metal is held at a temperature which is close to its melting point, and also it is under constant stress over over time period, it will lead to strain. That strain is called creep. So how do we define creep? Creep is defined as time dependent plastic strain of a material under a static load or constant stress when it is held at its temperature which is close to its melting point. So those are the three things. That is, it has to be held at the temperature close to its melting point. Second is it has to be subjected under constant stress or static load, and third is it happens over time. So it is always time dependent. I hope you have got the definition of creep. Now, when we talk about the metals which are used in dentistry for cast restorations or as substrates for porcelain veneers, they do not show creep. They are not susceptible to creep when the metals as such they are used. But what happens if we use the alloys of the metals? So in the alloys we have certain other components also which have melting point below or close to the mouth temperature. So in case of the metal alloys, they can show creep. So important example of these metal alloys which show creep that you have to remember are the dental amalgams. So dental amalgams which contain about 42 to 52% weight percentage of mercury, when they begin melting at temperatures even slightly above the room temperature, and they slowly show creep from the restored tooth side. That is, if we have used this amalgam restoration in the tooth side, they will start to show creep. That is, there will be a marginal breakdown, shrinkage under the periodic sustained stress. For example, if our patient is having a habit of clenching teeth, so these clenching of teeth is causing constant stress, and also the temperature is very close to the room temperature of this alloy, so there will be strain. That strain is called the creep, which will cause the marginal breakdown or marginal leakage of the restoration and the failure of the restoration. So that is why it is very important, creep is very important for dental amalgam alloys. Now let's talk about what happens to the prostheses where the metals are used. So if we are using dental prostheses which may show creep, it can lead to their destruction. Again, very important. So that is creep. Now what is flow? Flow is used to describe rheology of amorphous materials. Creep is for metallic metals. Now flow is for amorphous materials such as waxes. Now what is flow? It is flow of a wax. So basically we describe it for a wax. Flow of a wax is a measure of its potential to deform. That is, it has a potential to change when under a small static load. Such a small static load, for example, even its own mass. That is, even its own mass, under its own mass, wax may deform. So that potential to deform even under a small static load that associated with its own mass is known as flow. So that is the difference between creep and flow. So creep is for metals, flow is used to describe for waxes. Creep occurs under constant stress, flow also occurs under constant stress. Even a small static load can cause flow. Now, because we know that creep and flow can lead to the destruction of our prostheses or the things that we have used in the mouth, so it is very important to test creep and flow of the different dental materials before using them in the mouth. So how do we test it? We can be using a method which is known as compressive stresses. That is, we take a material and we put it under compressive stresses. Though we can use any type of stress, but usually we use compressive stresses to measure creep and flow. So compressive stresses is basically like two forces are acting upon the material in a straight line and opposite to each other. So what do you think what these two forces will lead to? These two forces will cause the shrinkage of the material, shortening of the material. So whenever we are doing testing for creep and flow, we are mainly using the compressive forces. That you have to keep in mind, compressive forces. Now how do we do this test? We take a cylinder of material, cylinder of a prescribed dimensions, we know its dimensions, and we put it is subjected to the compressive stress. We know what kind of stress we are giving in a specified time and temperature. So all those three same things we are using here. That is, we are placing it close to its melting temperature, we are using constant stress, and in a specified time. So what will happen? Yes, there will be strain. So that strain we will measure, and that will tell us that how much creep is shown by that material. So creep or flow is measured as percentage decrease in the length that occurs. So because of these compressive forces, there will be decrease in the length of the material. So that percentage decrease in the length of material is called creep and flow, which is happening in these circumstances. So that is how we test creep and flow. Now, what is the clinical significance of this creep and flow? We discussed about dental amalgams. So, if we are using certain dental amalgams like low copper amalgam may show creep and may cause unacceptable deformation of the restoration in the mouth. As we discussed, it can lead to marginal breakdown of the restoration, and it may cause the failure of restoration. So what you have to remember here is that it happens in the low copper amalgam. Very important. This can be sometimes asked in the MCQs. Which type of amalgam shows creep? It is low copper. So low copper amalgam shows high creep, and vice versa. That is, high copper amalgam will show low creep. So second point is that it can also cause unacceptable fit of the fixed partial denture frameworks. Suppose we want to give a fixed denture in the patient's mouth, and we prepare a framework for that in the lab where we are using a cast metal alloy, and that cast alloy will have poor creep resistance, that is it is prone to creep whenever we are using high temperature. So when we are using this cast metal alloy to veneer it with porcelain, now that porcelain is fused to this metal alloy at high temperatures, so we are using high temperatures. So at those high temperatures, so these alloys will show creep and it can lead to the changed fit of the framework, so unacceptable fit or destruction of the prosthesis may happen. So those are the two important clinical significances of the creep and flow, that is in case of dental amalgam, low copper amalgam restorations, and second is in case of FPD frameworks, fixed partial denture frameworks, it can lead to unacceptable fit. So that is all about creep and flow, and that is what all you can write for your short note: what is creep, what is flow, and how we can test them. Now let's check what have you understood. So which one shows highest creep? High copper, low copper dental amalgam, glass ionomer cement, or composite resins? So we discussed that low copper amalgam shows high creep. Second question, creep is associated with reduced corrosion, reduced tarnish, marginal breakdown, or improved hardness. So what happens due to creep? Yes, we know that it leads to the marginal breakdown. Then third is, which phase of dental amalgam is responsible for high creep? We know that high creep is seen in low copper amalgam. So in low copper amalgams, there is a presence of a phase which is known as gamma 2 phase, which is basically tin mercury phase. So this phase is present in the low copper amalgams, which is responsible for its high creep. So that is important for your MCQs, that you have to remember that it is gamma 2 phase in the low copper amalgams which causes high creep. So that is all for today's video. I hope you liked the video, and we discussed the properties in today's video, that is creep and flow, and in the upcoming videos we are going to discuss more properties, and also we are going to discuss other subjects as well. So keep watching, do subscribe to our channel, like and share this video with your friends, and keep smiling. See you in the next video. Till then, take care. Bye bye.